Do I move you? Are you willing? Do I groove you? Is it thrilling? Do I soothe you?
Alright, section 1.4 is on surface area and volume of prisms. You've done both these things before, probably many times before. And I know for a lot of you, surface area freaks you out. So I tell you what, let's not do it today. Let's just do volume today. Okay, next day we'll do surface area. Today we'll just do volume of prisms. We'll split it into 2 days. So we need to know what volume is, we need to know what prisms are. First of all, prism. A prism is a three-dimensional solid with two congruent parallel faces, and the parallel faces, the congruent parallel faces, those are called the bases. Congruent means exactly the same size, same shape. Exactly the same. So there's two, and I think you know what parallel is, right? Just like the two L's in parallel, they remain the same distance apart from each other. They don't get any closer to each other. They don't get any further away from each other. So, for example, if you look, let's start down here. If you look here, what are the two faces here that are parallel to each other and exactly the same shape? It's the triangles. Those are the bases. Now I know that might confuse you because often we speak about bases as being the thing it's sitting on, and this is not sitting on the triangle. But that's the way it is with prisms. You call the congruent parallel ones the bases. So this is a base, this triangle, this is a base, this triangle. How about in this one here? Again, the two shapes that are exactly the same and congruent and parallel are the triangles. So these are triangular prisms. You name these things by their base. This one, well, you've got squares all over the place. This is a cube, right? So it is called a cube, but you could also call it a square prism because, I don't know, it doesn't matter which ones you take. You could take the top and the bottom or the right and the left or the front and the back. In either case, you've got the congruent parallel ones. Now, if you look at these one, all the pairs, top and bottom, right and left, front and back, they're all rectangles. Even though the top and bottom looks like squares, they're not. This is 4, this is 7. So this is a rectangular prism. So that's what a prism is. Volume, you know what volume is. You might not remember how to define it, but the way to define volume is it's the amount of space inside a three-dimensional solid. It must be three-dimensional. It makes no sense to ask what the volume is of this red rectangle because this is only a two-dimensional shape. You could ask what the volume of this shape is because it's three-dimensional. When you find the volume, the units are always given in millimeters cubed or centimeters cubed or meters cubed or whatever. Those are called cubic units. Okay, now the volume, the formula for volume. You might not have ever seen it this way, but this is the way I've started teaching it in the last few years, and I think it's preferable. I don't know. You don't have to do it this way, but this is the way I like to do it. The volume is equal to the area of the base times the height of the prism. This formula will always work for every prism. This is how you can get the volume. So another way we could write that is volume equals capital B for area of base times h for the height of the prism. Okay, so let's try a few of these. First of all, what kind of shape did we say this is? You name them by the base. So the base of this is a square, so this is a square prism. And the way we're going to get the volume is we're going to get the area of the base. Well, that means we're going to get the area of a square, because that's what the base is. And then we're going to multiply that by the height of the prism. Okay, how do we get the area of a square? Do you remember your area formulas? If not, the area of a square is length times width. You could also call it side squared, but I find that almost no one does that. Length times width, and then we'll have to multiply that answer by height. Okay, now let's put our numbers in. What's the length of this thing and the width? The length and the width are 3 and 3, and the height is also 3. So 3 times 3 times 3 is 27. And, oh, what does this mean, this dot dot here? You know what dot dot means? That means inches. 3 inches by 3 inches by 3 inches. So it's 27 inches cubed. Now, I know probably a few of you are saying, That's not the way I learned it. What I learned is the volume of a cube is length times width times height. And you can see I did say that right here, length times width times height. That's fine, but if you want to do it that way, you're going to have to memorize one formula for cubes, one formula for rectangular prisms, one for triangular, one for... You have to memorize all these different formulas. Whereas if you just memorize this one formula up here, that'll work for all the different prisms. That's why I like to do it this way. Okay, next one. This is a rectangular prism. So the volume is equal to the area of a rectangle times the height. Now, which face here is the base? By the way, let's go back to this one. Which area which sides were the base here? It doesn't matter which one you call the base. They're all the same. So I don't know. Maybe you called... Probably the one you would think of as the base is the bottom one down here, right? Probably you thought of this as being your base, and that's fine. 3 times 3 would be your base. In this one, which one do you want to be the base? Again, they're all rectangles, so it doesn't matter. Let's tell you what, let's use this one since it's already kind of shaded. Let's call this one our base. It really doesn't matter. So we want to get the area of a rectangle times height. Area of a rectangle. How do you get the area of a rectangle? Length times width times height. So you can see that square prisms and rectangular prisms are exactly the same. Okay, length times width of this thing. So what are the two dimensionals? What are the two dimensions of this face here? Well, this is 4, right? Because it's parallel to this, and it's also parallel to that, and so those are all the same. So it's 4 times, how much is this? Well, that's parallel to this, which is also parallel to this, so it must be 10. 4 times 10. So if this is our base, what's the height? This would be the height, 7. 4 times 10 is 40 times 7 is 280 centimeters cubed. Always cubed. Okay, next one is a triangular prism, because those are the two parallel and congruent faces. So the volume will be area of the triangle times height of prism. Now this one confuses people because we have the word height showing up twice here. You'll see what I mean. Do you remember what the area of a triangle is? If you don't remember, I will tell you. It's base times height divided by 2, and then we're multiplying by the height of the prism. Now, do you see what's confusing about this? We have base times height, and then we have the height of the prism. Is it the same amount? No, they're different. So remember this bit here, this base times height over 2, this is just the triangle. So we're only looking at the triangle here. Okay? And the base and the height, maybe I'll write this down, the base and the height in a triangle always meet at a right angle. So they haven't drawn the right angle in this question, but you should be able to see it here. They should have drawn it so you know for sure it is a right angle. Maybe it's not, but let's just assume it must be. That's a right angle right there. So what are the two sides that meet at that angle right there? They are 3 and 4. The base of this triangle, I'm not talking about the base of the whole prism. If we just look at this triangle, the base of the triangle is 4, the height of the triangle is 3. So it's 4 times 3 divided by 2. Then we're going to multiply that by the height of the whole prism. What's the height of the whole prism? It's kind of like if you think of cross sections. When you're looking for height, it's like cross section, cross section. If you were to cut it and cut it and cut it and cut it, every time you cut it, you get another triangle, right? How many triangles high can you go? What's the height of it there? How many can you go? 11. You could go up 11 centimeters of those cuttings. Hope that makes sense. So 4 times 3 is 12, divided by 2 is 6, times 11 is 66 centimeters cubed. This one's also a triangular prism. It's a little bit different though. The last one had a right triangle on the bottom there. This one doesn't have a right triangle for its base. So triangular prism, again the base is going to be the triangles. So the volume is going to be area of triangle times height of prism, right? Not the height of the triangle, it's the height of the prism. So that means it's going to be base times height of the triangle divided by 2. This is to do with the triangle, times the height of the entire prism. So base and height in a triangle meet at a right angle. There's the right angle. So the base must be 10 and the height must be 15. We'll divide that by 2. And then the height of the entire prism, right? Cross section, cross section, cross all along here. How many? 20 centimeters of them. So this will give us our answer. 10 times 15 is 150, divided by 2 is 75. 75 times 20 is 1,500 centimeters cubed. Okay, there's one last type of prism you need to know. We've done square prisms, also called cubes. We've done rectangular prisms, triangular prisms, and the last one is this. What kind of prism is this? Well, the two congruent parallel faces are the one right at the top here, shaded yellow, and the one below. What do you call those shapes? Those are trapezoids. This is a trapezoidal prism. Of course, these aren't the only prisms. There's also like hexagonal prisms and heptagonal prisms, all sorts of them. But these are the ones we're going to worry about. Okay, you might not remember how to find the area of a trapezoid. So let me draw a trapezoid. Well, that's not drawing, that's cheating. But there's a trapezoid. The way you get the area of a trapezoid is area equals A plus B times H divided by 2. What's that all about? Well, in a trapezoid, what makes a trapezoid is you have two parallel sides. Here they are, top and bottom. Call one of them A, call the other one B. It doesn't matter which one you call A and which one B. A and B are the parallel sides. H is the height. This is not the height. It has to be at a right angle, so it would have to be something like this. This would be your height, or you could draw it here or here or here, any of these places. And you're going to take A plus B multiplied by H and divide by 2. Okay, so if we wanted to get the volume of this, volume equals area of trapezoid. Again, we have two heights in this question, times height of prism, not the height of the trapezoid, the height of the prism. Okay, we just saw that the area of a trapezoid is A plus B times H over 2, and then we're going to multiply that by the height of the entire prism. What's our A and what's our B? Well, if we look at the trapezoid, this is the base, this yellow thing here. You could also look at the one on the bottom, but let's look at this one. The parallel sides are here and here. Okay, so how much are those? Well, this one's obviously 2. How much is this one? Well, it's parallel to down here, it's 5. So A plus B is 2 plus 5, or 5 plus 2, it doesn't matter. Height has to be the height of the trapezoid. Just look at the trapezoid, it must be right here. Let's assume that's a right angle, it must be. So that's 3 divided by 2, and we're going to multiply that by the height of the entire prism. Trapezoid, trapezoid, cut, all these. There's the height right there, 6. So 2 plus 5 is 7, times 3 is 21, divided by 2 is 10 and a half. 10 and a half times 6 is 63 and centimeters cubed. Alright, finally we have some composite shapes. Composite because they're composed of more than one shape. Composite shape. So the first one, what do we have? We have a rectangular prism sitting on a rectangular prism. You might think this is a cube. It does look like a cube, but it's 4 by 4 by, how much is this? It's not 4, it's actually 5. It's the same as that one there. So it's actually two rectangular prisms. Okay, let's call this one A, and let's call this one B. And obviously what you're going to do is you're going to have to get the volume of A, get the volume of B, and add them together. So to get the volume of A, that's equal to the area of the base, and the base in this case is a rectangle. And they're going to multiply it by the height. In fact, this is going to be the same for B as well. So the area of a rectangle is length times width, and then you multiply it by height. Length and width of this A up here, well, let's call the, we can call the base anything we want. Let's call the base this top one. Why not? We'll do that. So the length and width, the dimensions of that shaded piece are 4 by, how much did we say that was? 5. So 4 by 5. And the height is this amount right here, 4. So that equals 20 times 4 is 80. Then we have to do the volume of B. Okay, let's skip a step or two. We know it's going to be the same down here, so we know we're going to end up with length times width times height. So in this one, let's take our base to be down here. So the dimensions of that one are 8 times 5, and the height of that one is 4. So 8 times 5 is 40, times 4 is 160. And then finally what you want to do is you want to add together for total what A is and B, add them together. So 80 plus 160, you get 240, and it's meters, so it will now be meters cubed. Last one, the famous barn question that you'll get all the time in these questions. Let's call one of them A, call the one of them B. You have to do them both separately and add them together. So volume A is what? That's a triangular prism. So we got to get the area of a triangle and then multiply by the height of the prism, not the height of the triangle. Area of a triangle we know is base times height divided by 2, and then we'll multiply by the height. Okay, so we're looking at the triangle. Remember that the base and the height meet at a right angle. The right angle would be right there. So the base is this amount. How much is that? 45. So we have 45 times the height of that triangle, which is 12, divided by 2, and then the height of the whole prism. How many triangles? Cut, 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 cut. How many triangles do you get there? 75 feet. 75. Go to the calculator. The answer is 20,250 feet cubed. And for B, well, B is another rectangular prism. So again, let's skip a couple steps. We know we're going to end up with length times width times height. It's totally okay if you do know some of these. So for that, let's take a look at, I don't know, again, we can look at any one we want. I know this is weird. We don't usually think of this as the base, but that's fine. Let's think of that as the base. What are the dimensions of that? Length times width, 75 times 18. 75 times 18. So then what would the height be? This would be the height here, the 45. And if you multiply those three numbers together, you will get 60,750 total. Add the two together. 20,250 plus 60,750 equals 81,000 cubic feet, or feet cubed. And that's volume. Okay, I hope that makes sense. Next day we'll tackle surface area, and good luck with the volume.
Are you hip to what I'm saying? If you are, then let's start swaying. The answer better be that pleases me.